All right, welcome back. So, as I was saying, so when you simplify this radical, be very careful. If you end up with a negative here under the you can't have a negative under the radical if the index is even. The index is 2. This is a square root, so you can't have a negative under the square root. If you end up with a negative, there is no solution. You stop the equation, you stop solving, you say there is no solution. That's why I say be very careful when you get A, B, C from the equation and when you plug and simplify. One mistake, one little sign wrong, and the whole thing could be wrong. So again, if you end up with a negative under the square root, that's undefined. You can't have a negative under the radical, the square root, so you say there's no solution. Okay, simplify, and if you're lucky, you get a perfect radical here. For example, radical 36, square root of 36, and there will be a whole number or an integer. X1 and X2 could be an integer, but if this is not a perfect radical, try to break it down as much as you can, simplify it, and basically find your the highest possible perfect square that can go into this number here that doesn't have a perfect radical. Okay, simplify if you can. Try to factor the numbers first. Okay, and that's basically it. So the solutions are here. You can also plug your solutions once you finish solving. You can plug the solutions into the very first equation that you started with, not if you moved, for example, something over, not the one after you write it in standard form, but the very first original equation that you have. You plug your solutions and see if that works. Okay, does that make sense to everyone?
Yes.
Okay, Shania, did you have a question about this before we got disconnected?
Yeah.
What was it?
How come we multiplied negative 19 times negative 16 instead of by 4?
I'm sorry, repeat that.
How come we multiplied negative 16? Negative 19 times 16 instead of negative 4 and 19.
Instead of negative 4 and 19. So because that's what the formula is. It's 4 times A times C. Negative 4 times A times C. So when you do the multiplication, you can do either one first. So we started with the first one. So we did negative 4 times A, right? Negative 4 times A. This is negative 16, right? And then multiplied that by negative 19. Multiplication, because C here is negative 19. So if you wanted to multiply these first, you can do that as well. If you multiply these two first, 4 times negative 19, and then times by negative 4, it will be the same thing. This is what we call the...
Add them together, right?
Yeah.
We do it separately.
I'm sorry, say it again.
So if you did it separate, if you did negative 4 times 4 and negative 4 times negative 19, you would add them together, the result?
So you don't distribute. This is not a distribution. Okay? It's just one multiplication here and one multiplication here. Okay? You're thinking about a multiplication distribution when you have parentheses. If you had 4, for example, multiply in parentheses 4 and 19, then you distribute. This is not a distribution, it's just two multiplications. Just like having 2 times 3 times 5. 2 times 3 times 5, you would do 2 times 3, right, which is 6, and then times by 5. It's not a distribution, it's just multiplication.
Okay, thank you.
Okay, so either way, you should get the same number. You see that?
Yeah.
So the unit 0.2, 9.2.
Yeah, that's the one. Page 577.
And which question are you talking about, Kala, from here?
Number 7.
Kala?
Yes. So the exercise number is 7. It's page 577.
Okay, so that's the unit again, 9.2. So we just did number 20. Okay. Kala, did you have a question?
Yes, can we make
We
22?
can't hear you. If you're talking, we can't hear you.
Yes.
Okay, now we can hear you. Go ahead. Did you have a question?
Okay. So can we do exercise 22? Same page?
22?
Yes, please.
Okay. 22. Let me see here. Let me just make sure it's from the homework. All right, so this was here. $20. So same question, solve using the quadratic formula. So again, we're gonna write the quadratic formula. And x is negative b plus minus b squared minus 4ac over 2a. So write your equation at first, so it's 26x minus 2, 3x squared. All right, so look at this equation here closely, and what do you think we do first? Everyone, what do you think we do first in this
I
equation?
think we add the +2 below the -2.
You want to do +2 below -2?
Yeah, so like the thing I was gonna say, like we should remove the 2 at first case.
Okay, okay. Just give me the whole idea. Okay, that's part of it. Like, what are you trying to do in general? What are you doing that?
So first of all, remove the 2 from the equation,
Okay, and after that?
and it's gonna be the 3 is gonna be 5x2. So we're gonna
Not exactly. Anybody else want to try? What do we do
You
first?
subtract 3x squared.
Shana, your sound is not clear. Can you get closer to the microphone?
Oh, sorry. You can subtract 3x squared.
Okay, that's part of it. What was the first step we look for, what we did earlier? What was the first thing we try to do with the equation? It has to be in what form?
Standard form.
Standard form. And what does that mean? All the terms are on one side, right?
Yeah.
So we have this term here. That's a good start. Kala suggested that we add 2 here, add 2. But if you add 2 here, you're not going to add the 2 to 3. You're just going to add it by itself because this is a constant number. This one has an x. So basically, we're going to add move both of these to the term with this power with the quadratic, with the second degree. Okay, so we're going to move this over and also this to the other side. Okay, we want to have, you won't make a big difference, but you try to have the quadratic term try to have it with a positive sign. Instead of moving this over and changing the sign of this to a minus, let's move these two over to the term with the second degree. So this will basically be something like this. So 3x squared, if you move the negative 26 over, 26x over would be negative 26x. When you move something, just change the sign, and then you're gonna move the negative 2 over, it turns into
Positive.
positive 2. What's left on this side if you move everything?
0.
0.
0.
Okay.
Yeah.
Now we can flip the equation. Okay, we can flip it. We can put the 0 on this side instead. Put the 0 here, and all these terms will be on this side. And this time you don't have to change the signs, because basically we're flipping the entire equation. This is the same as this. We just flipped it. Now that's standard form. What do we do after standard form?
You plug it into the formula.
We need to extract, first get A, B, and C, right? What is A, B, and C here? What's
A
8?
is 3.
That's right. A is 3. What is B? So that's A.
26.
Negative 26.
Negative 26. And
And this is plus 2.
It's
plus 2. That's right. C is positive 2. Good. So now we got these numbers. What do we do with them?
Substitution.
Say it again.
Substitution in the first equation.
That's right. We're going to substitute. We're going to plug or substitute all these values into the equation. So x will be, again, put some empty parentheses for b. What is b? Negative 26 plus minus 4 squared. Again, always put some empty parentheses and plug the 4. The 4 again is negative. I mean, the b is negative 26 to the second power minus, again, 4 times a times c. What is a again? A is 3.
3.
B,
Negative 26.
I mean C. C.
Oh, 2.
2.
C is 2. Make sure the fraction extends under the whole thing. So all the way here, starting from the beginning, over 2 times. In parentheses A, what is A? Again, is 3. Okay, get your numbers right, plug them correctly, and then be careful to simplify this. So what is this? So x will be, start from here. So what do you do now?
So,
Positive 26.
Positive.
That's right. Negative turns into positive 26 plus minus. And over
Isn't it-
here, what is negative 26 times negative 26? It's going to be a positive number.
52.
Say it again.
52, if I'm correct.
676.
It's 26 times 26, which is?
676.
All right. Thank you. It's a positive number.
Yeah.
And here again, so we got to multiply these two first. What's negative 4 times 3?
Negative 12.
Negative 12 times that by 2.
Negative 24. Sorry.
Exactly. And then the whole thing over 6. That's good. This number is positive, so we're going to have solutions. If this number ends up negative here, then you stop here and you say there's going to be no solutions because you can't have a negative number under the square root. All right, let's simplify this further. So x, please subtract this. The x will be 26 plus minus radical over 6. What's 672 minus 24? That would be
652.
52, that's right. 652. I believe that's a perfect square, if I'm not wrong. Square that number. It'll be 26. What is the square root of 625?
25.
25. Perfect. That's what you want to get. If you're lucky, you get a perfect, just 25, not the radical. Square root of 625 is just 25 over 6. Very good. So this one is a bit easier from the previous one. It doesn't have a radical here. Now we need to simplify more. Okay. But to do so, we're going to have to split this. We're going to write one with a plus, one with a minus, because we have whole numbers and integers. We can get clearer or more simplified solutions. So we're going to call this x1 and the other one be x2. Okay, let's take the first solution with a positive. So 26 plus 25 over 6, and the other one minus 25 over 6. 26 plus 25, that would be 51, right? 51 over 6. Can we simplify it? This doesn't simplify, right? 6 doesn't go into 51. And for the second one, x2, 26, take away 25, it's 1 over 6. And those are the solutions. You don't have to write them as decimals. I believe that's fine. And you can write your solution set like this. Yes, for solution set. Then you can say this, curly braces. Then you list your solutions from the lowest to the highest. Which number is smaller, x1 or x2?
x2.
That's right, x2 is smaller, so 1/6, comma, 51 over 6. And that's the solution set. Double check again. So if you want to double check this, if you want to double check these two solutions, do you plug them in this equation, 1, or this equation here, number 2? Which one do you plug this into? If you want to check for your solution. If you want to plug, say again?
In the standard form.
Actually, it's better to plug into the original form.
Oh.
Because this, you could make a mistake here. This might not be right. You could have made a mistake. Let's say you moved the negative to over, but you forgot to change the sign to a plus and you put a minus. So this is your equation. It's unreliable because you could have made a mistake. But we go to the original one to check the very first equation. That's where you check your solution. Because we can't trust this. We can't rely on it because we can easily make a mistake and get the wrong equation. Okay, does that make sense?
Yes.
Yes.
Thank you.
All right.
Yes.
Very good, very good. So one more thing, let me just double check here, make sure everything is good.
I think something is wrong.
Something is wrong, okay, let me double check. On
676 minus 24 is 652.
652. Okay,
Yeah.
someone who gave us that value. That's possible. Who gave us the value here? We should not have trusted you, whoever that was. Who did the 6? Now you're hiding yourself. You don't want to admit it, right? Who gave us that value? Okay, let me check here. Minus 24. You're right. It's 652.